kick into it. Tēnā koutou katoa. Welcome everyone. Today we're presenting on Snack and Learn on unlocking Auckland's rail network, CRL, particularly focused on the North Auckland Line connection. First of all, just a couple of bits of housekeeping. You should see in your panel down the side that there's opportunity to ask questions in the chat. There'll be time for questions at the end. And also the handout for today is available in the handout section of the chat. So today, in today's presentation, we will discuss what is CRL, its benefits, a brief introduction to the North Auckland Line, and then focus in on the staging strategy, how we got to it, and some of the key aspects of that for a brief summary at the end. So who are we? Hi everyone, my name's Dave Idle. I'm a technical director in the Bridges group, but for this project, for the Alliance, I was the NAL area manager. I've been involved in this project on and off since 2018, with my latest role kicking off pretty much as COVID hit last year. Darryl?
Hi everybody, I'm Daryl Osterbake and I'm a major projects director for WSP in Auckland, New Zealand, and I'm also the Link Alliance's design manager for the North Auckland Line scope of work. I've been involved since the Link Alliance took on this scope and have developed it through detailed design.
Thanks, Daryl. Now we're both just going to drop our videos off until the questions at the end, so you should just see the presentation now until then. So what is CRL? So Auckland is a growing city of about 1.6 million people. We've had significant growth in the rail network over this century. So the last 20 years or so, we've seen upgrades of Britomart Transport Centre, which is down here in the middle of the screen, twin tracking of the rail network, and then the metro rail network has been mostly electrified. So that's resulted in some pretty significant growth in patronage over the last few years, and with that growth in population, there's a significant advantage to provide additional capacity using CRL. CRL enables a doubling of rail capacity and doubles the number of Aucklanders living within 30 minutes travel time of the CBD, and provides this high quality rail corridor where there was none. At a high level, the project is a 3.4 twin tunnel up to 42 metres below ground, connecting the previous dead end at Britomart Station, which is here at the waterfront, through to Mount Eden Station, which is here on the North Auckland Line, with this running out towards the west. The current rail network being everything's coming in through here and then down into Britomart. It's expected to finish in 2024, and there's an overall cost of $4.4 billion, which is the largest project in New Zealand. There's been a number of contracts to deliver the project. The main contract has been this portion that's highlighted here, the stations and tunnels, the North Auckland Line connections, which we're going to talk about in a bit more detail, and the rail systems integration and testing. This contract is being delivered by the Link Alliance, which is a CRLL, Downer, Vinci, Saltanche, AECOM, WSP, and Tonkin and Taylor, with our key partners, Auckland Transport and Kiwi Rail, and the sponsors from the New Zealand government. Drop down into a little bit more detail of the North Auckland Line. So this is the North Auckland Line. We're now looking the other way up. So the city centre is up here to the top of the page. We've got a live rail line which is approximately 1.2 kilometres long, with the only link out to the west of Auckland. It's currently twin track with only Mount Eden Road. This intersection here is the only one that's grade separated. The other road and pedestrian grade separations haven't been undertaken yet. To enable the train frequency and operational capacity that we just mentioned, requires full grade separation, and we're creating a link up here into the tunnels and putting in 4 tracks in these locations where there were once 2. So that's in the east-facing connection here to this side, and the west-facing connection here. And so this is the Mount Eden station site that I mentioned on the previous slide, and this is the tunnel portal heading up towards the north. As a brownfield site, there's obviously a very constrained corridor, lots of existing roads, utilities, and then all of these existing buildings along the route. So one of the tricks to this is how to stage and build the rail line whilst minimizing disruption to the network. And an integrated rail and civil solution was required to enable this. Looking at the various options available to do this, the option selected by was to use a long single line running solution, running from approximately here to here, called long rather than short, as it's running the full length of the site, as opposed to providing a crossover at some point in the middle of the job. This has been enabled due to the fact that the Mount Eden Station NAL portion has been closed for the duration of that single line running, and that enables the headways and timetabling to work on the long single line. The integrated solution that we've used is it's used both existing civil and rail infrastructure as much as possible, so that we're trying to minimize those stages. And we're using existing scissors that are located roughly where they're off to the left of the screen. And then we require new scissors as part of CRL. And they're installed early so that we can then use the existing rail line at grade for the first stage of single line running. We can then switch over to the new track, which we're building offline, and then build the other side and then complete the whole project. I'm going to pass over to Daryl now to go through that in a little bit more detail.
Thanks, Dave. Yeah, so just following on from that scope summary by Dave, I was just going to discuss the construction staging in a little bit more detail. So hopefully the next slide comes up. Yep. Using some snipped images from the Fuser 4D model that we've developed, which basically we can take our federated 3D BIM model, and it's been linked to the P6 program. So we've taken a few snips from that to show in white each stage of the single line running alignment, to try to explain that in a bit more detail. As Dave has mentioned, predominantly we are doing track lowering into a newly formed trench to provide grade separation below the road network and to create the connections both from the east and western sides into the CRL tunnels. So we've undertaken that in 2 main single line running phases, including the reconfiguration of rail systems for each operational configuration, which has involved a bit of complex consideration around constructing civil infrastructure works, but still maintaining a system integration. What you can see here on the screen is you can see the main single line running alignments in white, hopefully, and the first, so I'm going to step through it in order, basically. First stage was to decommission the existing MC10 track. So what you can see here is that that track is gone, and the white line is the single line running on the MC40 track. That allows us to create room on the northern side and to construct the civil structures and the top-down grade separations in the east and west that form the 2 CRL connections. It also allows us to install the main combined services route utilities that work with the rail systems, and install some new rail systems infrastructure on that side for the next operational configuration. So once we've done that, we construct the new MC10 track, which passes over the 2 grade separation structures that we are constructing top down. And then, so basically we're running then on the newly formed MC10 track and its new alignment, including the crossover of the east-facing connection, west-facing connection, which are the dive structures that go in and connect to the CRL tunnels themselves. We commission that track, we decommission the MC40 track, which was there before, and then we construct on the southern side of the boundary whilst also excavating beneath those new grade separation structures to form those CRL connections. Finally, we then commission the new MC40 track, and we also commission the MC20, 30, 50 and 60, providing those connections to the CRL tunnels themselves. All up and around this work's happening. We've also got offline, off-corridor roading works to be done, including new footbridges at level crossings, newly constructed grade separation at Normanby Road, and top-down road bridge at Mount Eden. Okay, so following on from that, I'm just going to move on to focus on the east-facing connection area and talk through that in a bit more detail about the staging in that area. So this is another view from our BIM model, and what you can see, what we'll step through is sort of 3 main configurational phases of this area. So just to get your bearings, we're looking west. You can see the Mount Eden Road. You can see the existing Mount Eden Road bridge with the road over rail bridge on the top left corner. That's where the 2 existing tracks were running, and now we're currently operating on one single line, which is that track in white there. So essentially we've been doing a whole lot of top-down construction whilst running on a single line running strategy through there with the hoarding in place. And that's involved construction of a new bridge on Mount Eden Road to allow the new CRL connections, the MC50 and 60 lines, to pass underneath Mount Eden Road. And that's been formed by top-down D-wall structures, which have been done in 2 phases whilst we shift traffic back and forth. We've also got some contiguous board pile walls on the north side, which allow that track lowering some 6 meters below that existing ground level there. And then we've got the major grade separation structure, which you can see there with the propping between 2 diaphragm walls, which facilitate top-down construction of that grade separation. In the orange there, you can see we're constructing a crossover slab, which the future MC10 track will go through, as I mentioned before. And so all of this is being allowed to be built offline whilst the trains still operate on single line running. And this is, I guess, one of our main phases of works where we're basically constructing the grade separation structures and getting them ready for that new operational configuration. This has been a bit of a subject of some value engineering that the Link Alliance has undertaken in this space. Previously, there was a plan to do a more traditional temporary works and then bottom-up box construction. And what we did there was just because there's some benefits around program risk mitigation and also some sustainability wins around quantity and carbon footprint, we've implemented that top-down solution, which basically involves the D-walls being installed from existing ground level or somewhere near to it, construction of those top props and the crossover deck, and then that means that we can de-risk the process of getting the MC10 track on top of that, and then we can go ahead and mine out underneath that structure whilst trains can pass over the top of it. Just a bit more about the structure itself. There are a few constraints in this area that we've had to work around. So we've got top props. This trench goes down about 17 meters in total from existing ground level down to the MC50 level, and due to the presence of some major existing stormwater infrastructure at depth, we've been limited in terms of our D-wall toe depth. So we've had to utilise temporary propping within the trench, as well as some groundwater relief wells, to ensure that we don't get temporary loss of support of those D-walls and maintain stability. Lastly, we've tried to incorporate some synergy with the installation of some of the future overhead line supports, including constructing on the crossover slab itself with some plinths for future supports. Thanks, Dave. I'll pass back to you.
Thanks, Daryl. So I'm just going to quickly run through a more detailed sequence in the west, in the west-facing connection. So this is the existing liners we've got. This is the new MC10 that we're constructing. And one of the areas I want to just focus on is the western grade separation. So in this area, it's quite it's pretty tight. So there's exterior walls and interior walls. So the final solution is looking like this. We've got the two outside tracks are high and the middle tracks are low. So there's a retaining wall on the outside, one on the inside, one on the inside, one on the outside again. But the key to unlocking the sequence through here has been around the western grade separation structure. So I'm just going to talk a little bit more about that. The western grade separation structure is carrying this MC10 line, and we've worked very carefully to make sure that the structure can be constructed offline, away from this existing line, which is staying in its current position. There's been no changes to that to minimize that operational change. So the solution we've gone with is a top-down solution. You can see the piles, and we've got a spine beam running down this structure, kind of ladder type scenario with props, and then a trough that's carrying the MC10 going across the top. The two-stage solutions you can see as we flip between here and here, the rest of this structure is built in the second stage, and this portion here is left out. So there's been some very careful coordination geometrically to make sure that all of this fits together and to minimize the amount of temporary works. There are some temporary works required in terms of supports to some of the props, just in this location where we can't get all the way back across to this side, but still need that support for the central beam. We're using a system of temporary support there that is then tied in the stage 2, and then the dig out can occur afterwards without affecting the live lines. We've worked together really carefully with the construction team and rail systems to make sure that the change between MC10 and MC40 is as seamless as possible. So we tried to ensure that all of the infrastructure is located, like the overhead masts, the CSR, combined service routes, and the signals are all located and live and not affected by any stage 2 construction. So that means that there's overhead masts supported on some of these props, for example, and that we've made sure that in this next step here, where we build these props, those props and the detailing adjacent to this track mean that it won't affect the live operation of that track. In addition, we've what's not shown on here, but we'll see in a second, is that there is the tunnel portal and the Mount Eden site itself is a massive site, and there's very constrained. So we've worked really carefully to make sure that the lifting of all of these elements is really carefully considered in terms of precast, making sure that it can be built quickly, but also that the right size cranes can fit in this space to make sure that it can be constructed. As you can see in the stage 2, there's a pretty cool architectural box girder footbridge that's constructed, which unfortunately don't have time to talk about here today, maybe a subject for another time. And so that's the sequence through here. It then builds the rest of the walls on this side, again through top down, to minimize that kind of critical path working in terms of making sure these lines are live at the right time. And just a quick plug for some of the stuff on the Alliance. There's some quite cool videos on YouTube if you haven't seen them already, but this is for those of you that haven't. It's just a snip from about a month ago, which is pretty much what it looks like now since we've been in lockdown. And you can see this is looking the other way. So this is looking from up here, looking down towards the tunnels. And you can see the shape here of the existing lines running live, and then you can start to see the shape of the trough being constructed. So it's pretty cool videos out there if you want to have a look at that. So that's us sorted. Just very brief highlights on the North Auckland Line. As you can see, it's quite a complex brownfield rail environment, trying to maintain live road and rail throughout. We've worked together as an alliance to have a design and construction that's optimized to try to minimize that disruption, which has required some integrated rail systems and civil solutions. And you can see we've some of the stuff that we've put out there in the on these slides. We've been using quite a lot of 3D and 4D information to support that work, and there's some other talks available on that have been given in the past. Thank you very much. We'll turn our cameras back on and have a look at some questions.
Thank you guys for a fantastic presentation. So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download the PDF version of the presentation from the handout box on the dashboard. Just apologies for the delay. The slides were not displaying as we wished, but yeah, working from home, not easy. We will start with the first question. Where they said that there are sustainability targets on this project, could you please let us give us more information about it?
Yeah, so we're striving for some ISCA accreditation on this project, which is primarily being focused on reduction in carbon footprint and quantities. So we're tracking that very carefully against the baseline carbon footprint that the reference that we've compared to the reference design, and then we've been striving very carefully to try to reduce quantities and carbon footprint in every kind of change or value engineering decision we do has involved a good aspect of that in terms of consideration for any change that we make. Anything to add to that, Dave?
Yeah, we've used the BIM model has been available to help us track that information. And I guess there's been some good focus around things like cement replacement. So we're not only trying to minimize those quantities, but then thinking about the source of some of the base material costs. I mean, there's obviously heat water sustainability than that. There's just a couple of highlights, but there's also heaps of information again on the CRL and Alliance websites if you want to have a look any further.
Thank you. What was the approach to safety in the design of the project?
Shall I pick that one up, Daryl, or do you want to?
You can start, Dave.
So look, as we mentioned, so obviously for working in live rail environment, safety and design has been really, really important, but we've had a very robust process on that on the Alliance, working together with our stakeholders and partners to make sure that the handover is going to be as smooth as possible, and we're thinking about that maintenance and operation throughout our design processes. We've actually, on this part of the project, we went through a fairly rigorous safety and design process around the footbridge that I mentioned in there, and just in terms of some conflicting parts of the design solution around throw screens and sept head and maintenance. And there's been some really productive conversations amongst all parties. We've really tried to elevate that conversation to the top of the agenda so that we're able to deliver a really good solution in that space. So there's probably some more information that the Alliance might share over time on the safety and design elements.
Thank you. The next question is, how did you manage the interaction with the local road network during the rail operational staging?
Oh, yep, I'll take that. So we've had some consent conditions that we need to adhere to around maintaining key routes, and you can see that there's obviously a couple of main roads that pass over the rail corridor, including Normanby Road and Mount Eden Road. And so we've basically had conditions around maintaining one or the other and concurrency of working, and we've also had to upgrade a couple of the key intersections around where those roads pass the corridor with intersection improvements, implementation of traffic signalling and some traffic modelling that goes behind to support those designs to demonstrate that adequate traffic flows and reduction in lost time have been achieved. So yeah, essentially there's been quite a lot of staging of the roading before we can close roads off to be able to construct those grade separated structures. Yeah.
Thank you. Next question is, how many trains per hour will run on the busiest segment of the new line?
Oh, off the top of my head, I think it's 24 trains per hour, but
yeah.
You might have to triple check the website. That sound right, Daryl?
Yeah, I think that's right. And yeah, just I think to note that the CRL project facilitates the ability to run up to that many per hour. Yep.
Yeah.
Thank you. What is the one most important challenge in this project?
I think the project overall has heaps of different major challenges, but I guess talking specifically to our section we just talked about in NAL, we feel that the staging is that we talked about today is probably one of the most important challenges, and how that works has been critical to the success of this part of the project. Daryl, anything to add?
Yeah, I agree. Like every decision and design decision we've made around solution or staging in conjunction with constructability and within the Link Alliance has been around that complexity around staging and maintaining a live rail operation. So yeah, I definitely agree with that.
Thank you. Well, we'll take the last question. What would be your key lessons learned for future similar complexity rail projects for Auckland?
I don't think we'll be doing another, oh, maybe we will actually. We might do another rail tunnel if we're lucky, eh? Do you want to go or shall I go?
I guess my view is that the complexity in the live rail environment can't really be underestimated, and you know, the importance of maintaining operational continuity. It's a very complicated thing to do. So every decision we make flows on to affect 5 other things, and so it's that whole kind of systems integrity piece is really important for a project like this.
Fantastic, thank you.
I agree. Yeah, sorry, I was going to say I agree. I think it's that kind of that planning, and to make sure that sort of the concept that you've got has been rigorously tested. Like we've just highlighted a couple of the details here, but it's quite easy to say you're going to do this operational configuration, but actually doing that and having that thinking around particularly the tie-ins and just all of the existing infrastructure, how that all fits together. That's actually the detail in devil in the detail is a classic phrase everyone likes to use, but it is really true. And just going from getting that right level of detail up front so that you're really confident in that solution and staging that you're going, so that you don't have any unexpected surprises as you go through the project.
Fantastic, thank you. We have additional questions, however, we don't have time. These questions will be answered by Dave and Daryl. So we're at the end of our webinar session. Please feel free to follow up with the team here via the contact details shown on the screen. And I would like to thank all attendees for joining today. Thank you for your time, early morning in Auckland. Thank you guys for presenting. It was a pleasure working with you.
Thank you very much.
Sweet, thanks very much.
Thank you.